Yes, hi guys. So today, just I want to talk about the next topic, case number 3, in which the denominator is having quadratic factors, non-repeated quadratic factor or distinct quadratic factors. Okay, when denominator is having a distinct quadratic factor or non-repeated quadratic factors, it may have repeated linear factors. It may have linear factors and repeated linear factors, but only quadratic factors which are not repeated, which are distinct one. So distinct quadratic factors, if there are in the denominator of a rational fraction or of a fraction, okay, then that can be divided into partial fraction by the following method. I'll just talk about that. Okay. How we have to write that non-repeated quadratic factor in the case of partial fractions. Sorry, in case of partial fractions, we have to find out partial fractions, okay, of non-repeated quadratic factors. Then what is the process of doing that? So that I'll talk about. Secondly, I'll talk about these questions which are based on the same kind of questions. Okay, when the denominator is having non-repeated quadratic factors, simply quadratic factors, maybe one or two quadratic factors are there. Okay, the method of this I'll talk about with the help of this one. Initially, how we have to divide that into partial fractions, rational fraction, partial fraction, that I'll talk about. And finally, when there is a quadratic factor which is independent from linear factors, etc. If it is quadratic factor in the denominator, then that will be further divided into parts or into partial fractions with the help of the previous method which we discussed in rational fractions, okay, integration of rational fractions. That situation we were having, if there is denominator ax plus b divided by ax square plus bx plus c in the denominator, then we could have this equal to, my numerator is equal to, let me take ax plus b, or it is if bx plus q. If it is in the numerator we have bx plus q, in the denominator we have ax square plus bx plus c, and that we were dividing into ddx, a into ddx of the denominator, okay, plus b. This is equal to the numerator of this fraction. Similarly, we will divide that with the remaining quadratic factor, which is finally obtained independent quadratic factor. If it is having linear factors as well as repeated linear factors, then it will divide that into partial fractions with the help of the previous method which we have discussed about, and some more methods I will talk about. What is the method of partial fractions, and then the method which we discussed in the rational fractions, okay, in case of integration by rational fractions previously. I'll take, after partial fractions, I'll talk about irrational factors also. Irrational factors or fractions, irrational fractions or irrational functions. I'll talk about how to integrate irrational fractions, that is next topic. Because sometimes we take rational and irrational fractions together, but I'm now dividing chapter by chapter, topic by topic. Like first rational fractions I've taken, then how to use partial fractions in case of rational fractions, then I'll talk about irrational fractions. That is next one I'll talk about. But after the 24th lecture, 24th series of lectures, I'm having a number of lectures because I have to complete these 35 questions and topic related. Okay, so that it takes time. It has a number of series of lectures, about 12 or 13 or 14 or sometimes 10 only, 11, 12. Okay, so this series of lectures of 21, 22, 23, 24 of partial fractions, we have number of lectures. Well, okay, that I'll discuss about. Now let me talk about what is the definition of this and how we have to know about that the denominator is having rational fractions. What kind of rational fractions are there? Well, let me write here. If the denominator of a rational fraction of a fraction has, if the denominator of a fraction or a rational fraction has non-repeated quadratic factor. Now we are talking about quadratic factor, non-repeated quadratic factor, non-repeated quadratic factors or factor. Okay, non-repeated quadratic factors. Then the process of linear factor of this type of fractions divided into partial fractions, divided, okay, I'm sorry, divided into partial fractions, divided into partial fractions in this way, divided into partial fractions in the following ways, in the following ways, in the following ways. Number one, suppose there is a denominator, if the denominator of a fraction, okay, of a of a fraction, or okay, of a fraction as ax square plus bx plus c in the denominator, then this kind of fractions are expressed as let me get px plus q, or suppose one form this one is there, one px plus q divided by ax square plus bx plus c. If I have to divide this, then we just write ax plus b upon ax square plus bx plus c. Okay, in this way we write the quadric. If there are a number of other factors, for example, let me take, so we write this factor, I mean this fraction in this way, ax square is repeated. But in the numerator we will have ax plus b. Then we have to find out value of a and b. After that, this value will be divided like this, or will be expressed like this. This is rational fraction. We have to find out value of constant. The number of repeated factors, let me take number of other factors. Okay, for example, if the denominator is having any number, let me take ax plus b divided by, this is x1 square plus a, or let me take plus c here, this is x2 square plus d here. Okay, this kind of factors, suppose two factors are there, it is expressed as a into x plus b divided by x1 square plus c plus, this is cx plus d, okay, or this is x2 square plus b, in this way. So this is the process. The number of factors, other factors are also there, they are non-repeating factors. If there are other factors, let me take number of factors. The fraction given has a number of distinct factors in the denominator, as a number of distinct factors in the denominator, then okay, so the two factors, I mean two constants are taken together for one factor, then two constants with first multiplied with x and other independent constant, and other independent constants. Okay, so two constants, then denominator, okay, factors in the denominator, then two constants with first multiplied with x and other independent constants are expressed, the each of the or every each of the factors in the numerator, each of the factors of the denominator denominators in the numerator. What does it mean? It means in the numerator. In the numerator we will have two constants, one multiplied by x and other independent. One multiplied by x and other independent. If it is x square, if it is x cube, then we write here ax square plus bx plus c. Three constants are required. If the whatever degree of the factor is there, that degree decides number of constants. Okay. Suppose this is x cube plus c, okay, or x cube plus x square plus anything in the denominator. If it is x cube, highest power in the denominator, then we will have three constants, ax square plus bx plus c. I mean three constants, and one will start with one power less than the first constant, second with lesser variable, I mean lesser degree variable, plus last one is constant free, the independent constant. In this way we will express the factors given. Okay, so let me take some examples here of questions they are given. So let me take them. Okay. Let me solve the first question. So this is the process of non-repeated independent factors or distinct factors in the denominator, okay, of a rational fraction or a fraction. If fractions are given and they are divided into partial fractions, if the denominator is having quadratic factor, we have expressed non-repeated quadratic factors, then what is the process? Let me describe this with the help of questions here. These questions are taken of the same type. Now, first question can be solved. I'll just talk about how it can be solved. Okay. If there are a number of factors here given, then we can have constant together. Or if the independent only one, or I mean finally we have obtained the independent quadratic factors in the denominators, then that is expressed in the similar way as we expressed in the previous lecture. I mean previous lectures, or rational fractions, integration of rational fractions. That was what? A into differentiation of the denominator plus b. This was expressed in the numerator of the given fraction. Okay, so that is the process how we finally solve the questions. I'll just explain everything after solving every question. Every question is very important. Let me take questions one by one. Let me take first question, then it will be very clear. First question is x square plus 4. Now x square plus 1 into x square plus 3 into dx. Now this question is having only x square variables in the numerator and denominator. Variable, second degree of variable x. Okay, so it is just a different type of question. I'll solve this in two ways. Okay, I'll solve this in two ways. What are the ways? Let me explain the first way, simple way. If here in this case x square in the denominator, x square in the numerator, if I put let me write putting x square equal to, let me take y. Okay, so this can be expressed putting x square equal to y. Therefore x square plus 4 upon x square plus 1 into x square plus 3 can be written as y plus 4 divided by y plus 1 into y plus 3. Now it has turned into linear factors, distinct linear factors. Now it can be solved with the help of the same method which we discussed previously. So now let y plus 4 upon y plus 1 into y plus 3 equal to a upon y plus 1 plus b upon y plus 3. In the same way as we have discussed, there is no change in it. If we can convert that into linear factors, so that is how the question can be solved. So this is simpler process. If the x here are given, similar variables are given in numerator and denominator, then we can convert this in simple form. Finally, we will substitute the value of y when they are independent. So that can be solved in this way. Now let me solve it. If I multiply both the sides by y plus 1, y plus 2, multiplying, let me multiply this multiplying both these sides, or let me take multiplying by y plus 1 into y plus 3 in both the sides. So let me take first equation, both the sides of first. We get this is y plus 4 is equal to a into y plus 3 plus b into y plus 1. Okay, this is second equation. Now, as we expressed or as we solved the questions previously, the fifth lecture, I mean 21st, 21st, 22nd lecture, in which repeated premium factors were given, or independent before that 21st lecture was 20, I mean non-repeated distinct linear factors were given. These are the distinct linear factors, the same process as now come up here. We will just calculate value of a, we substitute y plus 1 in here, and this is y plus 3 in here. For a, okay, y plus 1 equal to 0 or y is equal to minus 1. Putting y equal to minus 1 in first, sorry, in second. This second one, this is second one. Which one? This is second one. In second one, let me substitute minus 1, y equal to minus 1. Only a will be calculated because this is 0, y plus 1 is 0, to be 0. This is minus 1 plus 4 on the left hand side. The right hand side we will have a into minus 1 plus 3. That means y is 3. Here it is 3. A is equal to, in this case, a is equal to 3 upon 2. This is plus 3. Okay, now what would be for b if I substitute? The denominator of b is y plus 3, y plus 3 equals 0. For b, we substitute y plus 3. For b here, for b, y plus 3 equals 0 or y equal to minus 3. Putting y equal to minus 3 in second, we get here. Now in this case, b will be calculated. B is minus 3 equal to b into minus 3 plus 1. So b, we have to substitute y equal to minus 3. B is nothing but 1 here. It is minus 2 minus twice b. Therefore b is equal to minus 1 upon 2. Okay. So a and b both are calculated. So finally this ratio, I mean this fraction, this fraction of this fraction is converted in this one, converted into 3 by 2 into y plus 1. This is minus 1.2 into y plus 3. Or now substituting the value. Finally, therefore x square plus 4, x square plus 1 into x square plus 3 is equal to 3 upon 2 into x square plus 3. We have substituted y equal to x square finally. Okay, this is minus 1.2 into x square plus 3. These two are, I mean this is finally transposed into, or is transferred into, converted into partial fractions, divided into partial fractions. Partial fractions of this factor is this. Finally this can be integrated. Therefore, integration of x square plus 4 upon x square plus 1 into x square plus 3 dx is equal to 3 upon 2 times integration 1 upon 1 plus x square into dx. For the minus sign, this is minus sign here. Minus sign 1.2 times integration 1 upon x square plus root 3 whole square. 3 here into dx. So this is integrated as 3 by 2. On here it is 1 plus x square to tan inverse x. This is nothing but tan inverse x integration 1.2. This is 1 upon root 3 into 1 upon root 3. 1.8 tan inverse x upon a. Formula is x upon root 3 plus constant of integration. Here it can be taken as constant of integration. Finally, these two values are 3 upon 2 tan inverse x minus 1 form root 3 tan inverse x upon root 2. Now in this case, this is shortcut formula. We have substituted x square equal to y and have solved like this. Okay? Or it could be solved in that situation. In that way, if I put the formula of that kind, that ax is every factor x square plus 1 is expressed as ax plus b upon this one plus bx plus cx plus d upon this one. There also the four constants are there. The value of those four constants are calculated finally. Then we have to solve these. I think those values will be like this. So finally we will get some answer like this. Similar answer. This is the answer of question number first. First is for so any process, whatever is going to make the fraction given in integrable fractions, positive fractions, these are integrable. This can be integrated easily. That is the process of solving the question. So any question, but this is the process. In case when x square in the denominator and both are, we can substitute that x square equal to y, converting that into real factors, linear factors. The word the process of linear factors that we have already discussed. The same way we can do this. So this is the answer finally. Okay. So let me also solve these kind of formula. Any questions that you have on the next formula which are just expressed of partial fractions. Then we have to assume the constant, two constants, first a and a into x plus b, a into x plus b plus c x plus d, like that for each quadratic factors. Okay, for each quadratic factor we have to assume that kind of. Okay, this is the first question we have solved. And let's talk about the second question. Now question number second. Let me talk about. Okay, question number second here. We are given 1 upon sine of integration 1 upon x into x square. Now here it is quadratic factor. One is x is a linear factor, no problem. This is including a linear factor, quadratic factor. So this can be done in the same way. So that it can be converted into 1 upon x into x square plus 1 is equal to, now here it is different from the first one. It can be written as a upon x plus bx plus c upon x square plus 1. Okay, again multiplying both sides of this by x into x square plus 1. Multiplying both sides. If we multiply this by this value, it is not only one will be left. I will just say that take this denominator that side, cross multiplication. So we will get, we are not taking these two to this side, only this one is taken to that side, that is also equal. It will give us a into x square plus 1 plus bx plus c into x only. Okay, so it will give us a into x square plus 1 plus b into x square plus c into x only. Okay, so we have to find out all the constants. Here, if I substitute x equal to 0, because a is independent, it's having linear factor x equal to 0. If I substitute x equal to 0, a value of a can be calculated. These two will be 0. For a, for value of a, as we were calculating previously, for value of a, putting or substituting, putting x equal to 0 in this first one. This is first one. Oh, okay, let me take this is the first one. This is the first one. Okay, no problem. In the first one, so we get here is 1 is equal to a, only a can be calculated. So a into 1 only. Why? Because this x square is 0, so 1 only. B0, C0, because x is 0. Okay, so a is equal to 1. Let me write here a is equal to. What about b and c? For that coefficients are compared. Let me equate the coefficients of x square, x, etc. Equating coefficient now, comparing coefficient of equating coefficients. Now comparing coefficients of x square, x, etc. Here x square is the highest power. Okay, so coefficient. So in this way we write. If there is another one, then we will write dx plus ce. So two constants are written. If it is x square, we write bx plus c. If it is x cube, okay, any x to highest power, then it will be bx square plus cx plus d, 3 constant. Whatever the degree of this denominator is there, highest degree, that number of constants are used. Okay, and this is in a descending order. If it is q, then x square plus x and so on and constant. If it is x4, then x cube bx cube plus cx square plus dx plus e. 4 constants will be required. So this is the process of taking constants in the numerator of every quadratic factor in the denominator. This is single, having x square only, so it is bx plus c. But if it could be, or it would be x cube, then it will be this x plus like bx square plus cx plus d. 3 constants. Whatever the degree, that number of constants are required. Now come to the point. Solving. Equating coefficient of x square first. Here it is 0, but no x square coefficient on the left hand side. It is a plus b here, x square coefficient. Okay, so a b have calculated, this is 1. The substitute here 1, so b is equal to minus 1. B is equal to minus 1 here. Now let me take x coefficients. There is no x here in a. Here it is left hand side 0, no x. But in this case it is c only. Okay, so c is equal to 0. No x coefficient, it is c into x, so here it is 0. So c equal to 0, no x coefficient. Alright, so c is 0 here. Okay, c 0. Let me express this now, c equal to 0. So finally, we can express the given equation in the form. Therefore, this equation is equal to a is 1 upon x plus b is minus 1 minus x, minus x upon x squared plus 1, only c 0, nothing else. Therefore, integration of this equation, integration of 1 upon x into x squared plus 1 into bx is equal to sine of integration 1 upon x into bx is 1 minus sine x upon x squared plus 1 into bx. Now in this case, we can substitute this is log of x only integration. In this case, we can substitute 1 plus x squared equal to 3 by substitution method, which is twice x into dx upon dt integrating by differentiating with respect to t is 1. Now here we will be like differentiating it with respect to t. We get this twice x dx upon dt will be called x into dx equal to dt upon 2. X dx is there. It can be written as 1 upon 2 dt upon t. So this is nothing but log of x minus 1 upon 2 log of t plus constant of integration. C by there, let me write here under constant, it is d constant. K, let me take constant. Log of x minus 1 upon 2. Now substitute value of t here. What is t? 1 plus x squared. This is the final value. Okay. Plus constant of k. Now this can be combined. Log of x upon this half power can be taken to this whole power. That will be minus log under root of 1 plus x squared. That under root 1 plus x squared will come in the denominator of log of this. So these two are combined together plus constant. This is the answer here. So answer can be this. It's the second question we have done. Now let me talk about next question. Now question number third one. So in partial fractions of this kind of questions are just expressed by taking constants. Number of constants will depend upon the degree of the denominator. Okay, so that in the numerator we have to select those constants according to the degree of the denominator. That is one of the information which I wanted to share with you. Okay, now come to the next thing. Question number now third one. Okay, so third question. Question number third is also of the same type. Step by step, I've taken those questions which are helpful to tell the student step by step process or procedure of this step by step, so that everything will be clear to the process of this integration. Okay, process of this partial fraction plus integration. Now again, This is a proper fraction. In this case, proper fraction must be there, which is already clear. If a proper fraction is not there, if it is improper, then we have to first convert it into proper fraction. That proper fraction, if denominator is having quadratic factor, which is distinct, non-repeated, then this process is going on. This is the case number 3, which we have distinct quadratic factors in the denominator. The denominator is having non-repeated quadratic factors, then we are discussing this topic. We should let 1 upon x into x square plus 4 is equal to a upon again x plus bx plus c upon x square plus 4. This is how we express these factors in this way. Now cross multiplying by this, or taking this, multiplying left and right hand side by this x square, x into x square plus 4, we get 1 is equal to a into x square plus 4 plus bx plus c into x only. This is again a into x square plus 4 plus b into x square plus c into x is equal to 1. Again, x a can be calculated for a constant x, put x will be 0 for a value of a. Okay, putting x equal to 0 in first. Take this is the first one. This is sorry, this is first one. Okay, anything can be conveyed. Putting this is first one. Putting in first, we get this is 1. A can be calculated here. This is a into 4 only because x is 0. A 4 into 4. Therefore, a is equal to 1.4. A is equal to 1.4. Now, what was B and C? For that, C can be now calculated easily by equating coefficient. Both B and C are calculated now. So for that, coefficients, equating comparison of coefficient on both sides, or equating coefficients on both sides of x square, x, etc. Here x square coefficient is 0 in the left hand side, it is a plus b only, a x square plus b into x square, that is a plus b. But a is 1.4, is 1.4 plus b, therefore b is equal to minus 1.4. Alright, what about c then? For c, constant is there, but x coefficient of x here is c, here is 0, 0 equal to c, constant